Unfortunately, Alyssa wasn't able to join our class today, so we're going to do a nice video and welcome her. Everybody say good morning, Alyssa.
Good morning, Alyssa.
That was not very enthusiastic.
What's up, Alyssa?
There you go. All right, so what we're going to do is we're going to go over the remainder and factor theorems, all right? And we're dealing with synthetic division. Okay? Right now, we're going to test to see if x plus 1 is a factor of this polynomial expression, all right? So technically, we're going to say this right here is the divisor. All right, that's the divisor. This right here is what's known as the dividend. All right, and we're going to come up with the answer, which is called the quotient. The quotient is the answer to a division problem. All right. Now, if I'm testing to see if x plus 1 is a factor, we're gonna plug in -1 as the root to see if that will work its way through the problem. All right. Now, in a polynomial function, a root is where it would cross the x-axis. Okay. When you're doing synthetic division, you need to set up some columns here. So as we work our way left to right, how many x to the fourths do we have? 1. Notice, do we have any cubic? No, we have none whatsoever. So no x to the power of 3. How many x squareds do we have? 1. -3. How many x to the firsts do we have? None. And how many x to the zeros do we have?
1.
We have 12.
How do you find the x to the zero?
That's a good question. Now, listen. The x to the zeros is just the constant at the end. So technically, Jordan, if I wanted to say, what is 12 times x to the power of 0? That technically is just equal to 12. Because any number to the 0 power is 1.
So you got the 12 from that last one?
Exactly. Okay, so you work your way down in descending order. You're going from 4 to 3 to 2 to 1, and logically the next one after 1 is 0.
I'm trying to work out a problem. Where do I get the 0 x?
Right. So, by the way, if you were to type this in the calculator, 12x to the power of 0, press enter, it would just equal a 12. Okay? Now, synthetic division is a faster way of division. What we're doing, guys, is we're saving our time and energy. If we didn't do synthetic division, here's what you would have to do. Don't do this on your paper. You have to say x plus 1 into, and then we'd have to write x to the 4 minus 3x squared plus a 12, and we have to go and do it the long way. That takes a lot longer than synthetic division. All right. So what we're going to do is we're not going to do all that long work. We're just going to learn this process. From those of you who had me last year, how am I going to start the process? Drop the 1 down. All right. What am I going to do with the -1 and the 1? Multiply together to get a -1. And we add these together. -1.
Wait, I got a question.
Sure.
How did you get the negative?
What are we going to do with the -1 and the -1?
Positive.
Multiplied, we get positive 1. Add these together. -2. Multiply them together. Positive 2. Add them together to
Hold
get
on, wait.
2 work.
-3 times 1 is negative.
No. -3 plus 1 is a -2. These right here, we always add these together. Anything that's right here, we add them together. All right, those are being added together.
Alright.
We're multiplying the -1 times the 2 to get -2. Then we add these together and we get a 10. Now listen, the last time we did this was trying to find a slant asymptote, and we said discard the remainder. This time we're not dealing with slant asymptotes, so we need to understand this is the remainder of the problem. So we're almost done. We have done the synthetic division, but now we have to interpret what these numbers mean. If this is x to the 4th, this is going to be how many x cubes get into it. So this always drops down 1. So if that's a 4, this is going to be x to the 3rd. If that's 3, what's this going to drop down to? squared. 2, that's going to be your x to the first. This will be your x to the 0. That'll be your constant right there at the end. So how many x cubes do we have? We have 1. How many x squared? So we have negative 1x squared. How many x's? Negative 2x. And then we have a constant of 2 at the end. Well, how do we figure out how to put this remainder at the end? We just say plus 10 out of, and we look at what our factor was, our divisor was.
Whoa.
No? What's our divisor? So you put 10 over x plus 1. Whatever your divisor is, Ryan, whatever it is, that's what you put underneath your remainder. Okay? This right here is what's called the quotient of our problem. All right? Which means if I took x plus 1, if I took an x plus 1 and I multiplied it to x cubed minus x squared minus 2x plus 2, and then I added the remainder at the end, if I took all of this and multiplied it, what would I get back to? I would get this times this gets me that right there. Okay? So this number times our answer would get us back to our original dividend. Okay?
And if there's a 0 remainder, then we don't have to put that in.
Correct. If the remainder was 0, then you would just leave it as it is. Okay? The remainder was 0. So if there's no remainder, then you could just put it in. All right, we're going to do one more problem together. We're going to do problem number 4 together. All right? We're going to do problem number 4 together. So let's go ahead and set it up. Now, sometimes in a textbook, a lot of times you'll see them do it this way. And if that's an x plus 3, they'll put a negative 3 right here. So there's more than one way to kind of set things up. I do it one way, some people do it another way.
Was that the answer to the quotation?
The answer.
That right there?
Right there, that's the answer. Okay? So I'm going to do a different way here. Just, if you like it this way, you can do it this way. All right? The other way I like this because it helps me organize things a little bit better. But a lot of times in textbooks, you'll see they call this the chair. They put the root right here. Yeah. This is we're testing to see if this is a factor. We're seeing is this a factor of this. So how many? Oh, I kind of messed up there. Sorry. How many x cubes do I have? I have 2. And I'm going to have a 3, negative 8, and a 3.
What's the?
So this is just another way of setting it up. All right. We do the same method. We drop it down. What are we going to do with the root and that number? Multiply it. We get negative 6. We're going to add those together. Negative 3. Good. No. Negative 8 plus 9. 1. Multiply. All right. So right now, this right here, we have a remainder that's equal to 0. Which means that this actually is a factor. It goes into it. For example, if I said, what's 4 divided by 2? It's 2. Is there a remainder? No. 2 is evenly divisible into it. But if I say, what's 5 divided by 2? You'd probably say 2.5, right? But it doesn't go into it perfectly. So there is a remainder. If you worked it out, the remainder would be 1 for that. Okay? So this one has a remainder of 0. Now what does that mean? That means, what's my final answer? If that's x to the power of 3, how many x? What is this 2 represent? 2x squared. This is going to be x to the first.
Okay.
thought it was 2x to the third.
Here's how it works. If that's a 3, this will be a 2.
It's just going to be one number of
One number less. It's always going to be one number less. Okay? So we know we have 2x squared minus 3x plus 1. And we're not going to add a remainder. This is our final answer. This is our quotient. Okay? Because it works it divides into it perfectly. There's no remainder left. Okay? Now I'll let you guys try the other two. Okay? Alright, on 5 through 12, I'm asking you guys to do something a little bit different. It actually takes less work, not as much work as we did on 1 through 4. But you still have to set it up correctly. First thing, we need to set everything up. I'm going to label my x to the fourths, x cubed, x squared, x first, x. Always do that. Every single time, list them in descending order, starting with your greatest, working to your least. If you're testing to see if x plus 1 is a factor, then we're going to put in a negative 1. We're testing this to see if it's going to work, because it's always going to be the opposite. Okay? Right here, you're going to plug in a 2, a 4, a negative 1, a 0, because technically we don't have any x's, and then we're going to finish it with a 9. And then we do the exact same thing we did on the first 4. Bring down the 2. Multiply these together, get negative 2. Add those together, you get positive 2. Multiply them together, get negative 2. Add these two together, get negative 3. Multiply negative 1 times negative 3, get positive 3. Add 0 and 3 together, you get 3. Multiply negative 1 times 3, get negative 3. Add those together, you get a 6. This right here is your remainder. If you get any number other than 0 as a remainder, this is not going to be a factor. Okay? Which means x plus 1 is not a factor of this polynomial expression. So here's what you say. You say, not a factor because the remainder was equal to a 6. I will be testing not just on whether it's a factor or not, but whether you got the correct remainder. Okay? Now, if the remainder is 0, then it is a factor. If the remainder is not 0, then it's not a factor. Now, here's something I didn't make you do. Technically, this is what? X to the third. This is x squared. This is x to the first. This is x to the 0. I'm not making you write out 2x cubed plus 2x squared minus 3x plus 3 with the remainder of 6 over x plus 1. I'm not making you write out that long expression. I'm just having you guys use synthetic division to test whether something is a factor or something is not a factor. So what am I looking for your answer? This right here. So on problems 5 all the way through 12 on your assignment, that's what you're going to be doing. You're going to be testing on whether something is a factor or if it is not a factor. And list what your remainder is if it isn't a factor. Okay? So I want to see your work. What work do I want to see on your paper? I want to see this.
If it is a factor?
I'm sorry, if it is a factor, the remainder will be 0.
Oh, so that would solve and see if it has a remainder or not?
And if it's 0, it's a factor.
So what do you write?
So I need two things. I need the remainder, and yes, it is a factor, or no, it's not a factor. Okay?
So you don't have to do that long part right there?
This part, I'm not making you write the quotient. I'm not making you write the answer that you would got on 1 through